All right. Today we're going to talk about number 32 in section 4.4 out of the Larson Calculus textbook. And it's a chain rule problem, and the question is, what's the derivative of g? So we have to find g prime. G prime of x is done by, there's a couple ways to do this. I think the main way to do this is just to see this as the inner function being 3x squared minus 2 over 2x plus 3, and therefore g could be written as u cubed. So we have an inner function of this quotient and an outer function of a cube. So we have to do the derivative of the outer function first. The derivative of something cubed is 3 times that something squared. So 3u squared. But what's u? This thing. So let's write that in there. 3x squared minus 2 over 2x plus 3 times the derivative of the inside. Now the derivative of the inside is this quotient, so we have to apply the quotient rule. Okay, so it is the derivative of the top. So this is a 2 comes down, we get 6x, and then minus 0, times the bottom, minus the derivative of the bottom, which is just a simple 2 plus 0, or the slope of this line is 2, however you want to think about it. And then that's times the top, so 3x squared minus 2. All over the bottom squared. So we need to simplify all this, and then on this left fraction, I'm just going to square both the top and the bottom. So I'll get 3 times the quantity, 3x squared minus 2 squared, and on the bottom over there, 2x plus 3 squared. And over on this fraction, I have a 2x plus 3 squared on the bottom. Take care of that first, that's the easy part. And then on the top, we have to distribute here, 12x squared plus 18x. And then over here, we have to distribute a minus 2, so we'll get negative 6x squared plus 4. Combine like terms here next. Okay, so if we combine like terms, we get 12x squared minus 6x squared. That is 6x squared. 18x and 4 have no like terms, so we just copy those down. And then all over 2x plus 3 squared. Okay, so we can now multiply the two fractions, and on the bottom, when we multiply those, we see it's just 2x plus 3 twice here and 2 more times here. So in total, that is 4 times. 2 plus 2 is 4. Okay? And then here what we can do is this trinomial has a common 2 we can factor out. So let's factor out that common 2 and get 3x squared plus 9x plus 4. Nope, plus 2. Okay? And then, I mean, is this factorable? So we're looking for possibilities of 3x and x, and then 2 and 1. There's really only 2 ways to do it. These 2 ways. Do either of these make 9x? Well, this makes 3x plus 2x, so no. And this one makes 6x plus 3x. Oh, but I screwed up. This should be a single x here. So this would be 6x plus 1x, so no. So this trinomial is not factorable, so the best we can do here is take this 2 and multiply it by the 3, getting us 6 times the quantity 3x squared minus 2 squared times the quantity 3x squared plus 9x plus 2, and then all divided by 2x plus 3 to the 4th power. Done. I don't think there's any better way to do that. Let's box our answer with some satisfaction.